Hi guys, welcome to my new video of AIM-AMIE. In this video we'll be studying about the defects in the crystal structure, and the main purpose of creating this channel is to support the working professional who studying AIM-AMIE. Please do watch my videos, please do support, please do share to your friend circles, to the working professional also, and please do subscribe. Thank you. Defects in crystal structure. So guys, let's start. The first one is the point defects, that is zero dimensional, followed by line defects. These are mostly one dimensional defects. Third one is the planar or surface defects. These are mostly the two dimensional defects. The next one is the volumetric, known as the volume defects basically. So in the point defects we have the vacancy. First one is the vacancies, then next one is the interstitialities, followed by impurity, impurity atoms. The next one is the Frankel defects, known as Frankel imperfections, and next one is the Schottky imperfections. Well, these two are very important in AIM-AMIE course. Then line defects. The line defects are classified into basic two types, known as the edge dislocation and screw dislocation. So difference between the edge dislocation and the screw dislocation is very important. The edge dislocation is classified as known as Berger vector, which is also very important. So we'll be studying this one by one. Also, there is some kind of planar defects. These are basically two dimensional, known as the grain boundaries, the faults in the grain boundary, tilt boundary, and the twin boundary. So the types in the volume defects are basically the proper sequence, that is faults in the sequence, and then is the stacking fault. It means the arrangement. So I'll be studying this one by one. First is the vacancy. The vacancy, in this vacancy is the atom is missing from its regular site, results in the formation of vacancy. How does the vacancy form? So basically the vacancy can be formed by some of this. The first one is the rapid quenching. So quenching is a heat treatment process. So first one is the rapid quenching from high temperature. The second one is the formation of intermetallic compounds. These are nickel aluminium, cobalt aluminium, and iron aluminium. Third one is the bombardment of the metals with high energy nuclear particles. These can produce both vacancies as well as interstitial. The fourth one is the plastic deformation. So due to the plastic deformation, the vacancy can be formed. Fifth one is the oxidation of some metals. So as we all know, the oxidation means the reaction of the oxides. So guys, the next one is the interstitiality. In the interstitiality, the atom of the same metal is entrapped inside the crystal lattice, which is locked at the site intermediate between the normal lattice positions. Over here you can see that the blue dot, which represents an atom, is surrounded by the green one, and which is trapped over there. So let us see how interstitiality occurs. The first one, it occurs in the pure metals by the bombardments as well, which are the high energy nuclear particles. The second one is the formation of solid, liquid, and gaseous state. The third one is the normally present in coils, sheets, and pipe and wire products. So over here guys, please write down the note, that is temperature, degree of deformation, radiation damage, which affects the both vacancy and interstitiality. The next one is the impurity atoms. The impurity atoms, these are the secondary atoms present in the regular crystal lattice. So crystal lattice is the main word, please write down. It is the contamination of composition. So over here you can see that it is the main interstitial. So the next one is the Frankel imperfections, which is very important in the AIM-AMIE course, and it is frequently asked question. So Frankel imperfection, when anions displayed from the regular position and interstitial creating a vacancy interstitial, is called the Frankel defects. Next one is the Schottky imperfection, which is a pair of one cation and one anion is missing from the ionic crystal. So guys, over here in the image you can see that this image represents the Frankel as well as the Schottky imperfections.